Continuing on with the notes, we have tangent circles. So two coplanar circles that intersect at exactly one point are called tangent circles. So notice that these two circles, this one in blue and then this one in green, they intersect at the point C. And then notice that point C also has this line, CD, going through that point. So remember, if you have a line that touches a circle exactly one time, we call that a tangent line. So notice that these two circles, the one in blue and the one in green, both touch at that point C that is a part of the tangent line. So this is why these two circles, their relationship between the two, we'd call those tangent circles because they meet at that point that creates the tangent line between line CD and then this blue and this green circle. Okay, so again, tangent circles, they meet at one point, and that one point in which they meet is where the tangent line goes through. So a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. So I brought this up earlier in that we have this tangent line L, and we know that it's a tangent line because if we look, we have the center of the circle here, and from the center of the circle to point P, that's the radius line. We know that because point P lies on the circle. And again, if you go from the center to a point that's on the circle, that's the radius line. And the image also shows that at that angle P, it's 90 degrees, meaning that we've just formed a perpendicular angle from this radii line to the tangent line. So if and only if we have that, where that line is perpendicular to the radius line, then we consider that line is in fact a tangent line, because that tells us that there's only going to be one point of intersection between that line and the circle that we have constructed. So two segments are tangent to a circle from the same external point, then the segments are congruent. Okay, so what that is saying is we have this point E here, and then line CE is tangent to line AC, and then line DE is tangent to point AD. To line segment AD. So what this means is then we're saying that we know that the length of CE is going to be congruent to the length of DE. And then the reason why we know this to be true is because if we go ahead and remember, by definition, in order to be a tangent line, that means that you've created a right angle where that line, that tangent line, and that radius line meet. Okay, so I know that this is a right angle here, and then I could do the same thing to this angle here. And I know again that this is a right angle because I have my tangent line. My radius line, by definition of being tangent, you have to form a 90-degree angle. So I know for sure that this angle here is 90, this angle here is 90. I also know that these two line segments have to be congruent to each other because they're both radii. So remember, if you have a radius line, another radius line, and they belong to the same circle, we know that they're going to be the same length. So now I know that this angle here is 90 degrees, this angle here is 90 degrees, and then I know that this side length here and this side length here are going to be congruent to each other. Then I went ahead and I added to this image that I'm drawing a line going from my center of my circle all the way to that point where those two tangent lines intersect. Now, the reason why I do this is because if we look at this photo, I have these two triangles here. And then notice, remember, we've talked about this before, that two triangles, if they share a side length, we know those side lengths are going to be congruent. So I could really go ahead and I could add in 3 little sticks to show that this side length is going to be congruent to this side length because they share this side. Now, if we should notice here in this picture that I have a triangle with a right angle, and I have another triangle with a right angle. So if they have this side length and this side length is congruent, and then they share this side so it's congruent, if we use the Pythagorean theorem, we would see that, of course, AC has to be congruent to BC because of the fact that our hypotenuse is the same for each, and then we have the leg length that's the same for each. So then if we do the Pythagorean theorem on both, we'd find that their other leg has to be the same length because that's the only way that the Pythagorean theorem would work out. So like here I have solve for AB and AC. Well, I have BA and then I have CA.